Okay, let's move on with the second half here of Sedimentary Rocks. There'll be a little less here. It's mostly we'll be talking about sedimentary structures. We'll be talking about bedding, and we'll kind of look at some pictures of what these things are. The feature you're seeing here in this image uh, is what's called crossbedding. And when you see something like this, I mean, you can see that little tree up there, so you know that thing's maybe 12 feet tall or something. But this, I can look at this as a geologist, and what I know formed this, which is big sand dunes, and I'll kind of get a picture in my brain of, wow, okay, there were sand dunes migrating back and forth once upon a time when in this area when these rocks were laid down. Kind of cool. So sedimentary structures can tell us a lot. So in the kind of the previous part of this chapter, we talked about the different sediments. We talked about kind of how we get a rock with the tridal or clastic sediments, and I talked briefly about chemical sedimentary rocks. Actually, this stuff I'm kind of leaving up to the lab. We'll actually look at the rocks, and maybe I'll talk a little bit more about chemical rocks in this little lecture. But let's jump into kind of sedimentary structures and what bedding is. And yeah. So, what's bedding? Well, a bed is something you lay down in, right? So, bedding in geology is kind of the horizontal rocks that we see. Here is some bedding. We can see these horizontal rocks going across here. You can kind of see the shadows that they make. You can see the lines. This is all just sediment that's weathering and eroding off of these sedimentary rocks. But this is bedding. It's rocks that have been laid down into beds. I showed you this picture before. Sorry, it's a little bit blurry. I actually snapped this somewhere in Tennessee when I was in a box truck. But this is bedding, right? Sideways, horizontal, rocks. Bedding. There's something we have called crossbedding. That was the original picture I showed you. These are cross beds. They're not quite horizontal, they're across. And these are reminiscent of when a dune will actually migrate. So if you can kind of picture, and I should get a better image of this, but if you can kind of picture a dune and wind blows against the dune, all the sand on one side of the dune will get picked up and blown to the other side of the dune. So it'll be picked up from one side and then deposited on the other side. Picked up on one side, deposited on the other side, picked up on one side, deposited on the other side, picked up on one side, deposited on the other side, picked up on one side, deposited on the other side, picked up on one side, deposited on the other side, and the dune will migrate. Now you're starting to realize what you're seeing here. And the dunes will sometimes migrate back in the other direction. Kind of nifty. That's crossbedding. And it doesn't have to be on this huge levels. Something like ripples can actually make little crossbeds as ripples migrate in the water. Here's some rocks here in Arkansas. We can see crossbedding in these rocks, kind of this diagonal bedding that isn't perfectly horizontal. And it's kind of usually characterized where you've got some and then you've got some more. But this looks like it's just normal bedding beneath it, just nice and horizontal, but this stuff is crossbedding. So that's kind of your first major sedimentary structure. I'd kind of say it's one of the most common that you'll see, and it kind of tells you a lot that, hey, this sediment was moving. It was kind of migrating. You can also see it here. You'll notice that there's bedding going this way, and it's kind of going diagonal down here into this other rock layer. I forget where this is in Arkansas. This may actually be over... I'm not sure. I don't want to say it. I don't want to be wrong. But this is a sandstone here, and you can kind of see this cross-bedding that's present. You can look over here and kind of see these lines going this way. Cross-bedding. This was a dune. Whoop, moving across that way. We also have something called graded bedding, which means the grain sizes are graded. It's from larger to smaller. Or honestly, it could even be in the opposite direction. But you'll notice there's bigger pieces of sediment down here, larger pieces of sand, not quite. Well, maybe that's almost gravel size. That's a nickel there. Is this thing bigger than 2 millimeters? Boy, it's close. But maybe some really small gravel, and it starts to get more sandy, and you got sand, and then it kind of gets silty up here. Maybe we'd call this a siltstone up here. Maybe this is a sandstone down here, but or just the sand grains get a lot smaller as you go up. But this is greater bedding. Big stuff on the bottom, medium stuff, smaller stuff. How do you get this? Well, we've got these little tubes in class I'll let you guys play with. You can shake them up, and they got pebbles in there, or they have gravel in them. They got sand, and they've got silt and clay in them. And you notice the heavy stuff settles out first. So if I've got a river that's just rushing by really fast, and there's a lot of sediment in it, and then all of a sudden it stops, that water velocity just stops, really slows down, all the sediment in there will start to just kind of fall out of the water, and it'll collect, and the heavy stuff falls out first, and the medium stuff, and then the light stuff. And so this kind of tells me that, there's a change in water velocity here, wherever this may have been deposited, and we kind of get this graded bedding. So there are other types of sedimentary structures. There's a lot. There can be a lot. We have stuff that's non-biogenic in that it's not created by life, and we have stuff that's biogenic that is created by life. So like dinosaur footprints, little animal burrows. You'll find a lot of rocks here in the Ozarks that are created by little burrowing worms. I forget the name of it. It's actually got a certain name, Astroidia or something like that. But it's kind of neat when you find it. You know it when you find it. It kind of looks like a bunch of fingers. So if any of you guys have any of that, that's what it is. It's little animal burrows. And I believe we have some in class, and I'll show it to you. You can get where roots are growing, and then sediment will come and fill in where the root used to be. The roots will die, and then sediment comes in and fills that in. And it's sort of a sedimentary structure. There's all these other different types. You do not have to memorize all these. I'm just telling you that there's these different sedimentary structures. Don't freak out. Oh my gosh, there's this huge list. Does he really expect me to memorize all that? No, I don't. Not at all. I may just ask you to list out, name 3 different types of sedimentary structures. Crossbedding, graded bedding, and the animal tracks. Or ripples. Or mud cracks. Speaking of, you know what mud cracks are, right? It's a sedimentary structure. Little ripples can get preserved. Sedimentary structure. Groove marks, flute marks. These are basically where if you look at a river, a flooding river, you'll see sometimes a tree or a branch going down the middle of the river. If it drags itself on the bottom of that river, it can create a big old groove in the bottom of the river. And if that gets buried, it can get preserved and show up later when the thing's a rock. And so you can get these marks. And there's also load casts, which I'll kind of show you what that is in class, and scours, which is pretty much what I was just talking about. So yeah, there's lots of different types of sedimentary structures. So let's go through some of them. Here are ripples. It looks like ripples. Very easy to identify. I know that this is neat. I can look at this rock and be like, I can imagine, man. I'm on a beach somewhere, like the water's maybe 3 feet deep. There's a little bit of an offshore current, right? It's just flowing a little bit to create these little ripples here on this piece of sandstone or siltstone. And so I look at this rock, and man, I'm on vacation, right? I'm somewhere on a nice warm beach, and I'm just reliving it. And I can sort of visualize, I can imagine the world that used to be by looking at this rock. This is why sedimentary rocks and sedimentary structures are so kind of cool. They can tell us a lot about what used to be in certain places in the past. And you will find these around here in northwest Arkansas. The beach used to be up there. We used to be underwater in the ocean. And these rocks are telling us that. They're telling that story. This is a paragraph of that story. Pretty neat. So here's kind of how, they can get preserved. You can kind of see the little ripple marks. You have a flood or something, you bring in some more sand. You can kind of bury this stuff. That's how it can get preserved. But this is the rock. This is kind of those ripples forming. Mud cracks are another one. A lot of us have probably seen mud cracks in just a muddy area, and then you dry it out, and the clay in there will kind of contract. We'll talk a little bit about that later. Northwest Arkansas is very prone to expanding and contracting clays. Make sure you have a good home foundation if you're buying a house, especially a new one. But you can also imagine if some flood happens, brings in a whole bunch of sand or silt or something and buries this, you can kind of preserve this. Hey, and here's what it looks like when you turn it into a rock and preserve it. These are mud cracks. I now know something about the environment that used to be here when this rock was laid down. Pretty cool. So, that's sedimentary structures. What's a formation? You may hear the term rock formation, and a lot of folks, I say, oh, it's a rock formation. And you picture, like, I don't know, the arches in Utah, or, something that's kind of unusual or magnificent or something. That's not really what a geologist considers a rock formation. Formations are just large beds of rocks. And we kind of have a definition for this. A rock formation, it's a little bit arbitrary what a formation is. It's something we just kind of decide. Somebody goes and says, here's these rocks. We're going to group them together. We're going to call them a formation. And in order for something to be a formation, it's got to be large enough and extensive enough that we can map it. Formations are put onto a map. The geologic map of Arkansas we have sitting on the wall maps out different rock formations. So it needs to be pretty extensive. It doesn't have to be all the same rock. It can be sandstones with shales and then more sandstones. It doesn't have to be all sandstone or all limestone. Sometimes it is, but it doesn't have to be. There has to be visible characteristics of these rock layers, sort of so you can define it. Oh, here's a sandstone and it has this special type of fossil in it. That's a visible characteristic that can kind of help us define that formation. It's got to be different from other rocks around it. And again, it's got to be really extensive. It's, if it only shows up on the side of the road somewhere, not anywhere else, well, we're not really going to call that a rock formation because it's not mappable. It's not very extensive. It's not how we're going to define something. So, here is the Grand Canyon. There are different formations in the Grand Canyon. A really simple one, this is called the Coconino Sandstone. This is one big sandstone unit, one big sandstone bed, and it's a formation. There's this other thing up here called the Toro Weep Formation. It's kind of sandstones interbedded with shales, but it's got its own definition somewhere of what the formation is. It's bordered by a couple of layers down here and maybe a big thick layer of sandstone up here. And also you notice this term called contacts. We'll call the spot between formations a contact. So that's worth knowing. Then up here, this is mostly limestones, and it's called the Kaibab limestone. So these are different formations. Even though this one's the only one that's got the word formation on it, these are all different formations. So I mentioned visible characteristics. It can be a number of things. It can be the color. There's something in the Grand Canyon called the red wall limestone. It's red. It can have something to do with the texture of the rock. It can have something to do with the rock type. It's like sandstone or even igneous rocks can be considered formations, right? It doesn't have to just be sedimentary. There's something in the bottom of the Grand Canyon called the Vishnu Schist. It's a formation. It's a metamorphic rock. Certain types of fossils we can use to help us define what a formation is. Certain sedimentary structures. If there's a really thick sandstone and it's all got crossbedding, like that very first picture I showed you, that can help us define a formation. Here's another picture of the Grand Canyon. I may show this one to you guys in class, and we may even sort of decide what our own formations are. I can kind of look at this and have a good idea of what formations are what, but I may show this to you guys, and we may decide what different formations are, but just kind of as a preemptive strike, you can see there's this kind of lighter layer right here, right? It goes all the way across. Maybe we'll decide that's one formation all on its own, and we'll call that, the Eagle Formation, the NWAC formation, whatever you want to call it. You get to name it. Congratulations, you're the geologist. And it may be everything above that, all these other layers. Maybe we'll call out a different formation. Or you know what? Maybe we'll take all this stuff and lump it in with this. And this will all be one formation. It's up to you, but you have to define it. So these are kind of what formations are. They've got to be mappable. They've got to be really extensive. And they're a little bit arbitrary. By arbitrary, I mean, you know, it's kind of up to us as geologists to define what these formations are. And generally, all the big rocks have already been defined. Geology's been around at least for 100 years as a decent science. So yeah, these already have names. It's not like you can go out to the Grand Canyon and start naming rocks and people will start, believing you or something. Another picture of the same sort of thing. Again, we'll probably talk about this in class. Same thing. So, how do we name a formation? A lot of times there's a type locality. So you'll pick kind of one spot. Locality is just a location, right? You'll pick one spot. You'll find that rock at that spot. It'll be a rock type. You notice in those first pictures I showed you, or even if I back up to this one, limestone, right? That's a rock type. Limestone. Mississippian red wall limestone. Red wall limestone. It's a red wall limestone. So we'll kind of use the rock type. A good example is the Chattanooga Shale. Well, where do you think the type locality is for the Chattanooga Shale? Another rock formation that's around here, south of NWAC, down in Fayetteville, and throughout northwest Arkansas, is the Atoka Formation. If anybody has driven between here and Dallas, you have probably struggled to not get a ticket when you drive through Atoka, Oklahoma. The Atoka Formation is, its type locality is in Atoka, Oklahoma. But that rock is very extensive, and it outcrops all the way over here throughout northern Arkansas. When we put it into a map, and we'll look at the geologic map on the wall at a later date, but you kind of have to figure out what the age is. On the map, there'll also be kind of the first letter of the type locality, so something like the Chattanooga Shale. On the map, you'll actually put a little C, and it'll represent the Chattanooga Shale, and it'll have a certain color. But we'll look at the geologic map later and talk about that, unless it's my next image. So you can see these different formations here on this geologic map of Arkansas. Like I said, we've got this big, nice one in class. But you'll notice up here in northwest Arkansas, Bentonville and Rogers is kind of up in this area. This is kind of where we're at. It's all one rock formation here at the surface called the Boone Formation. And down here, when you get into Fayetteville, things start to change. There's other formations. There's mountains here in Fayetteville, which are different rocks than the stuff that's kind of at the bottom but beneath the mountains. And as you go further south, there's different rock formations. And you get down to the Ouachitas where things are a little bit more chaotic and you get different rock formations. And you get into lowlands of Arkansas where the Mississippi River is, and all these kind of the river valley as it's called. And you get different formations, and they're much different rocks and they're much different ages. Everything up here is on the order of hundreds of millions of years old, and this stuff over here is just tens of millions of years old, if that. And you've got the Arkansas River kind of coming through here through the river valley. So you've got some of this these younger formations that are in here mixed in with these older rocks because that river has its own deposits. Anyway, so what about the interpretation of some of these sedimentary rocks and kind of what they tell us? This is just a list of your rocks that we're going to have in class. I'll give that to you later. We've seen this before. I showed this to you last lecture or in the previous video. Again, you have a source area, you have a mountain somewhere, you're weathering and eroding this, and you're transporting the sediments down, usually a stream. And over time, the heavier stuff either gets deposited somewhere or it gets beat up further into smaller and smaller grains, and eventually it gets deposited. Same thing going the other way, just a different picture. Yeah, I'm kind of beating a dead horse, but I want this in your brain. This is important, how sedimentary rocks, clastic sedimentary rocks, detrital sedimentary rocks, same thing, right? It's the chunks. How these things are kind of how it evolves and how we end up getting these different sedimentary rocks. Because if you look at a sedimentary rock, if you look at a shale that's made up of clay, you'll know that it was deposited in a very quiet area, probably a deep water sort of area. And when you hold onto a piece of shale, I want you to visualize, wow, this is under deep water somewhere, and the water was very still. Whereas you're holding a maybe some sand and a sandstone, you'll think, oh, this is a beach, or maybe this is like a sandbar on a river. And if you're kind of holding gravel, stuff that's really angular, like, oh, this just kind of fell off the mountain somewhere. So it must have been deposited near the base of a mountain. Regarding depositional environments, like I've mentioned, rivers are their own sort of depositional environment. Rivers will migrate back and forth. So this river over time will kind of go back and forth and deposit more material back and forth. The sediment deposited in a floodplain is a little bit different than the sediment that's deposited in the bottom of the channel. The channel of the river moves quickly, right? It can transport sands and gravels, and then if it kind of slows down, you'll get this sand and gravel there in the bottom of the river. But when you get a flood and this whole area is covered with water, the water isn't really moving very much, right? If you've ever seen a flooded river, it doesn't, in the middle of it, yeah, it's moving fast, but the areas on the outside, the water's barely moving. So when it overflows its banks, the smaller sediments, the clays, the silts, can get up out here onto these floodplains and deposit these other rock types. So these can maybe be shales and mudstones, whereas this is a sandstone. Kind of a complicated example. Don't worry too much about it if you didn't follow that whole thing. We'll talk about rivers later. Rivers are their own whole thing. This is that kind of in the real world. You probably don't know what to make of this, but here it is sort of drawn out. You can see this little bottom lobe right here, right? There's lots of gravel and larger rocks in this little lobe. That's the old base of that channel of that river. And over time, it migrated back and forth. There's more deposits on top of it. And the areas where you see the finer grains, right? You don't really see any gravel over here. We maybe can't tell whether this is sand, silt, or clay, but we can tell this stuff in this area is more fine grained than this stuff, right? This must have meant the water was not moving very fast, or there was hardly any movement at all when it was deposited, versus, holy cow, water was fast. Another depositional environment. This is called an alluvial fan. Alluvial fan, you'll find it in your book. It doesn't take much imagination to figure out what's going on here. This is sort of a river coming down here, and that's actually a road along there. That's a river coming down here, I think. But here's these mountains. There's this valley right in here. This river is carving out this valley, and when it gets into this valley floor, it's not falling so fast, right? There's not so much of a slope here, and when it gets down to here and it hits the basement of this valley, which is flat, all of a sudden the water slows down, and all of a sudden it just throws up all over here, and you get what's kind of like a river delta, right? You can see like the Mississippi River Delta, which is this huge kind of splaying out of sediment. Well, it can kind of happen on land too when you come out of mountains, where the slope of the river changes and all of a sudden the water isn't moving as fast, and the stuff that the water was carrying just ends up being deposited all over the place. When you bury this stuff, this is where you get your conglomerates and your breccias and your gravel based sedimentary rocks, which we'll look at in class. But when I have a piece of conglomerate or a breccia, or breccia if you want to call it that, this is kind of what I picture in my mind. Something like this is where it must have formed. Cartoon drawing of what we just saw. The mountains are kind of weathering stuff out. This is just an alluvial fan kind of showing what happens. So you get layers of coarse, angular, feldspar-rich sand. So the feldspar is still in there from these granite mountains. It's not quartz. It's a little bit of everything. It's not well sorted. It's not well rounded. most likely. And yeah, depositional environment. So here's a whole bunch of depositional environments. I think this is a great. I think this is a great little picture. You've got mountains up here. You've got glaciers. We'll spend a whole chapter on those. They're doing some weathering and eroding. You've got these alluvial fans like we just looked at. Lakes. You can deposit sediments in the lakes. You have the floodplain out here, and you have the river channel. And the rivers are our real major sediment transporters, right? The rivers are the ones that are doing most of the work. When we kind of learn about erosion as we're growing up, what the K through 12 teachers may not tell you is that, they say, oh, it's wind and water, wind and water, wind and water. Well, here on planet Earth, it's mostly the water. It's almost always the water. And in particular, it's the rivers that are giving us these big sedimentary layers that we see sometimes on the side of the road that are making up the big layers of rock that are underneath our feet here in Arkansas. The rivers are carrying that sediment out to the coastline, spinning it out into the ocean because our velocity is dropped, right? All of a sudden we're at the ocean, the sediment isn't going anywhere, and it falls out. And so we'll get all our sandstones forming here near the coast. We'll get maybe shales out here, or siltstones, and then kind of into our shales. So sand, silt, clay. And there's some other neat stuff that goes on where you may have a little bit more deposition and transportation happening under the water, where you get these submarine valleys and canyons. And we'll talk a little bit about that when we get into ocean basins. But this doesn't play a huge effect of the rocks we see, but it plays some, and it's kind of neat. But yeah, different depositional environments. Now we have a reef over here. The reef is not very close to the river. The reef is made up of life. It's made up of coral. It's made up of shells. The reef likes being here and not over here because there's not sediment being dumped on top of it, right? Corals and life does not want to be living in muddy water. Life needs sunlight. It doesn't want to be eating mud all the time. That's difficult to deal with. So in areas where you don't have sediment being dumped out, clastic sediments, detritus sediments being dumped out, we'll start to find reefs forming, and then we start talking about the chemical sedimentary rocks, which are mostly dominated by limestones. And you'll even get, here's where, you bust this stuff up or you bury this stuff and you end up getting fossiliferous limestones that are full of fossils. Back here, you'll end up getting kind of really muddy, limey stuff called micrite. We'll look at that rock. It looks a lot like a mudstone, but when you put some acid on it, it fizzes like crazy. It's made out of calcium carbonate, the same stuff these reefs are made out of. When you hit these reefs with waves, right, you can imagine this ocean's got waves coming out of here. Hurricane coming by is going to create a lot of wind and a lot of waves, and it's going to beat up these reefs. In addition to that, you've got fish that are just munching on these reefs, and something called a parrotfish will actually eat coral, and it'll get what nutrients it can out of it, and it'll poop out what's left over. And I'm sorry to tell you this, but a lot of the beaches you go to on vacation, if they're not made out of quartz sand, they're made out of the pooped out reef of those parrotfish. So you can have beaches that are made out of carbonate. They're made out of these chemical sedimentary rocks that are made out of limestone. It's just the beat up remains of that limestone. Big scary table. This is just kind of showing different depositional environments, the alluvial fan coming out of the mountain, the river, the lake, the beach, the lagoon area, which is kind of the backside of that reef, the deep sea or the reef itself. Energy is just kind of talking about how much is the water moving. The more the water is moving, the larger grains of sediment that we can get, if any at all. So here's the rock types we'll kind of see: alluvial fans, we'll get sandstones, we'll get conglomerates, rivers, we'll get just about all sorts of sedimentary rocks, sorry, the clastic sedimentary rocks, the detrital sedimentary rocks. And lakes will get shales because they're kind of quiet water, right? A river runs into a lake, the water slows down, out comes the clay. Beaches, you'll get quartz sandstone a lot, or sometimes it'll be calcium carbonate sand from beat up limestone. Lagoons, you'll find shales and micrites. Deep sea area, you'll find shales and chert. We'll talk about what chert is here in a second. And then reefs, you'll find limestones. And then all the structures you'll find, the textures you'll find, and anything else. I've kind of already talked about this, but I just wanted you to visualize what happens if you erode out a mountain and it flows down, say, the Arkansas River, all the way down here. You start out with a sediment that's really poorly sorted. It's angular. It hasn't moved very much. There's all sorts of different grain sizes. And as it travels over time down this river, you start to abrade it. You start to dissolve some of the minerals that are in there. The feldspars, the micas are gone almost immediately. The feldspars start to disappear as you get out here. And by the time you're pretty far down this river, the only sediment that's left in the river is the quartz sand. Because the quartz sand is so hard, it's beat everything else up. Either everything else is dissolved into ions, or it's been beaten into clay. It's just so small you can't even see it. So at this point you've got quartz sand and you've got a lot of mud along with it, which is just the clay. And you get down here to the bottom and you're mostly depositing the quartz sand down here on the beaches all around here. But when you get over into Florida, you notice there's not much for rivers around here. This area of Florida is dominated by chemical sedimentary rocks. It's the corals, it's the reefs that are kind of deciding what rocks and what sediments you're finding around here. Whereas up here along this coast, again, you're getting the Appalachian Mountains, weathered and eroded, and so you're actually getting quartz sand up here. But a beach, if you go around here, these areas, the beach is far different than the beaches are around here. These are typically the beaches we like to visit. There's not a whole lot of sediment in these areas. There's not a whole lot of clay and mud and everything like you get down here in the Texas Gulf Coast and the areas. I mean, nobody even wants to go to the vacation around here. Things are so muddy, there's so much sediment in the water, blah. But over here, you don't have any rivers coming out. The water is nice and clear. The beaches are all made of calcium carbonate. They're all made of the coral material. When you get off the beach a little bit, a lot of times the mud that's out there is micrite. So that's kind of what's going on along our coast here. Just kind of wanted you to visualize the transportation of those sediments. We'll talk about this a little bit later when we get into Arkansas paleogeography and history. But Arkansas, what we have here today is not what used to be. The rocks we have here today were deposited when things were different. And this is 92 million years ago. It's quite a bit long time ago, but the rocks we actually have here in northwest Arkansas were deposited about 300 million years ago, so much longer ago than this. But it's sort of just an introduction to geologic time. Things have happened over time. The world used to be a different looking place. This is a little bit recognizable because we've thrown in the map of North America. But if I didn't have that in there, what is this? You might not even recognize that this is North America. Maybe this is Game of Thrones, and this is that map from Game of Thrones. I don't know. But yeah, very, very different world. You can imagine that there was depositional environments that were different around here, and you had different types of rocks being deposited. Let's look at this side. See all these mountains? See how there's no mountains really in here? You can imagine the sediments being deposited in these areas are not very sorted. They've got all sorts of minerals in them. We have something called an arcosic sandstone, which means there's quartz sand in there, there's feldspars in there, there's lots of stuff. It's not very well rounded. Versus over here, where the sediments you get, maybe just quartz sand and some shales, and kind of what we're seeing today. Or maybe not at all. Maybe this is all just calcium carbonate. Maybe this is all just chemical stuff and limestones. So I just kind of wanted to kind of show you this and get your brain thinking about stuff we'll talk about later on. And this is for the lab.